The last logarithmic property that I would like to take a look at is what's called the change of base formula. So if you remember, or maybe you've already realized this, that your calculator probably only has the ability to calculate things in log base 10 and log base e, or in other words, natural log. So if we want to be able to use our calculator for things besides those bases, so if we had something like, say, log base 2, how could we use our calculator to help us find those? So this formula will allow us to do that. So log base b of m. So if I just give any type of log with any type of base and anything on the inside, I can rewrite this as log base n of m divided by log base n of b, where n is any base of your choice. So if you're trying to use your calculator, you're going to be choosing base 10 or base e, or basically log or natural log. Those are going to be your go-to options. This will allow you to calculate anything with your calculator without having to do any type of weird change to exponent thing. Now, the way that I remember this formula is log base b of m. The base is going to go low. So I remember base goes low. So the base goes on the bottom and the inside goes over here. So if we see this example of log base 5 of 7.68. Now, most calculators can't do this, so we do the change of base formula. So I can choose any base. I'm going to choose natural log. So natural log of 7.68 divided by natural log of 5. So this number goes up top, the base goes low. And when I type in natural log of 7.68 divided by natural log of 5 into the calculator, and you should get something like 1.267. Now this one over here, log base 6 of 36. If you do this, you could approach this the same way that you did a little bit ago with changing this into exponential form. So just a brief recall, you could change this, call this x. You'd have 6 to the x is equal to 36, so x is equal to 2. You could do this, that's fine. But if we instead use the change of base formula, this could be equal to natural log of 36 divided by natural log of 6. Type this into your calculator, and you get 2. So you don't have to do that anymore. You can just use the change of base to calculate these things without turning them into exponential form. So it's a very nice formula. It doesn't get used pretty much for anything besides just having it for weird bases for your calculator.